All right. So we'll get started here. Thanks, everybody. So today's session is going to be about governance and security in the cloud. So to get into it, first, I'm Jeff Spazzetti. I'm a member of the product management team at Hortonworks, and I focus on some of our cloud solutions. And I'm joined by Srikanth, Venkat.
So I'm responsible for product management for security and governance areas. So we'll talk about how we are thinking about security and governance in the cloud from an end-to-end perspective, and we want to share some early previews, etc., with you to kind of get maybe some validation as well as your support as we push this product forward.
Yep. So how do we put these two together? So we'll do a little brief intro and talk a little bit about how we've seen some cloud usage patterns happen, at least from a deployment and workload perspective. Then we'll do a little bit about just make sure folks are familiar with what the building blocks are of how we start bringing governance and security into that with Ranger, Atlas, and Knox. Then we'll actually talk about, okay, how do we actually put them together? And then we'll do some demos along the way and give some findings and takeaways that we found. So to really start off and level set, what we've seen occur a lot, especially in cloud environments, is how do you actually enable an ephemeral workload case? So not necessarily a multi-workload cluster, not necessarily a long-running cluster, but actually think more ephemeral so that you're only using cloud resources when you need them. So purpose-built clusters, spin them up, use them, spin them down. So what that brings with it is kind of the idea that you have to work really well with cloud storage. So good integrations with Amazon S3, WASB, ADLS, things like that. So just with this background there, and as we started poking on this over the past couple years, we started saying, well, there's got to be a way to bring this to bear. And we also discovered a few things about security and governance, and that's what we're going to end up hitting today. So some of the demos we're going to do today actually build on a product we have out there called Hortonworks Data Cloud. So is anyone familiar with it, heard of it, tried it, type thing? All right, cool. A few folks out there. That's cool. So this is actually something that's available that you can try today. It's really around that prescriptive ephemeral use case scenario for Spark and Hive. Spin up those workloads. They're attached. they're ready to work with S3 data. And so you can actually do kind of like purpose-built cluster, run that workload, work with your S3 data, tear it down. So we're actually going to build a lot on this. So we're going to show this evolution here and how we inject governance and security in there. But I did want to at least make sure you saw where we're starting from an ephemeral use case perspective and S3 perspective. So switching over, I'm actually looking at Hortonworks Data Cloud right now. And so I've actually spun up a couple clusters here. That one is really based on analytics. So it kind of has Hive LLAP in there, and anyone who's seen the Hive LLAP sessions, I think there was a couple of them over the past couple of days. This is kind of the quickest way to get access to that engine. You can launch it. It has Hive LLAP pre-configured. JDBC access is ready to go. Point your Tableau to it or anything else and start using it. Similarly, there's a way to spin up data science type clusters that are really around Spark and Zeppelin use cases. So you can spin these things up and have them there. In both cases, it's really about having you spin up these workloads and start working with S3 data, and you spin these down when you're done. So really ephemeral workloads with S3 data. We give people other choices when it comes to the workloads they want to run, so different versions they might be interested in, whether it's a Spark 1.6 cluster or they're looking for more of a traditional ETL cluster with Hive. So we make that available too. But at the end of the day, this is kind of like a control plane for you to manage your workload clusters, spin them up when you need them, tear them down when you're done. So what we did when we created this product and started, poking on it a bit more, what we learned is, the ephemeral case and the cloud storage case, we have to start thinking a little bit differently about how you inject security and governance into that world. In a traditional cluster, you would actually go and inject a Ranger and an Atlas and a Knox into each individual cluster. But since these clusters are really short-lived and ephemeral, we have to think about it a little bit differently. And that's what we're trying to bring together, and that's what we're going to show as we evolve from ephemeral cloud storage and bring Ranger, Atlas, and Knox together. So we're calling this really about how do you bring data lake security and bring those services together into the cloud environment. So some of the building blocks and the key building blocks here are Ranger, Atlas, and Knox. And I want to hand it over to Srikanth to kind of give you an overview on those just so you have that piece, and then we'll work on putting them together.
Thanks, Jeff. Right, so for those that are not familiar with this picture, so this is our security stack, in essence, distilled into one slide. So our 10-year, or I guess 11-year-old elephant now is sitting in the castle. We want to protect this with different layers of protection, security around, all the way around the castle. So from the outside end, we have network segmentation firewalls, which is represented by the moat. Whatever you do within the castle is moot unless you do that properly. So you will see some of that as we set up the clusters in the cloud, becoming even more important. At the front door, you have limited entry points. So you have this drawbridge, Apache Knox. That is your API gateway, provides security for REST APIs and proxying of the UIs and other services that we'll talk about. At the front door, you have your soldiers or guards checking your passports, which is your LDAP and AD, checking your identity while you get into the castle. All around the castle, you have these watchtowers, which is Apache Ranger, watching all the access requests, what's happening, logging all of those, and also authorizing those requests. Within the castle, you have these high hard walls, which is your component of service-to-service communications. Those are Kerberos and wire encryption. And all around the walls, you have these thick, heavy, all around the castle, you have these very heavy, thick walls, which is your HDFS transparent data encryption. So this is kind of a picture of all parts of our security stack and how they kind of relate to each other and all the different components that play in that. So in specific, what we are looking at here in the cloud context is starting from the outside in, we have Apache Knox as the gateway that will secure API and RESTful access, as well as be able to proxy the different services. So Knox provides 3 areas here of capabilities. The first one is around proxying different services. So we provide access to Hadoop via HTTP, and also ecosystem APIs and UIs can now be secured outside in, and also provide the link into Kerberos and SSL termination, as well as impersonation via DOAS. All of these proxying services are available via Knox, and you can see here on the left all the different services, the UIs that can be proxied, as well as the RESTful APIs that can be proxied here. Knox also provides authentication. There's a variety of schemes. We provide, LDAP, AD type of lookups and authentication, as well as header-based pre-authentication. So we can call out to another service such as Tivoli or other services that might have and get a pre-authenticated header from those and process that to authenticate users. Kerberos, SAML, as well as OAuth have been enabled with 2.5 and are improved in 2.6. The SAML v2 can be used for SSO for UIs. Currently, in 2.6 version of HTTP, Ambari, Ranger, and Atlas have been enabled. So we will continue to add more UIs to the SSO flavors here. The third piece here, which is around API or Knox API and Knox Shell, which is can be used as your DSL to write scripting and create and manage different topologies to authorize different services within your cluster. Second piece of our security stack, which is foundational and central to our security story here, is Apache Ranger. Ranger provides a comprehensive and extensible security model. First piece being very broad coverage across the platform to authorize different types of resources and services, everything from HDFS files, folders, to Hive columns, tables, databases, Yarn queues, Kafka topics, Solar indices, Storm topologies, and so on. So all of those components can be authorized at a very fine-grained and granular level with Ranger using this unified framework. And we've also made sure that this framework is accessible with a plugin model where you can write your own plugins for other contexts. For example, we have Microsoft, which has taken the range of plugin framework and build plugins for WASB and ADLS storage. We have Pivotal that has taken this and extended this to the Hawk infrastructure. So we'd welcome other partners, those of you here who are looking at other contexts, to be able to take this and extend that to your environments. The other second foundational area that Ranger offers is the centralized auditing capability. The central audit here means that every single access request, along with the user context and the request context, is captured and persisted, and that is scaled along with the cluster. So all of these audits get written back to HDFS. The most recent 90 days worth of data is indexed and available via the real-time visual query interface that is available with Ranger. We'll see some of that when we look at the demo. The third piece here is fine-grained authorization. We already talked about this at the different levels that make sense. And also the ability to sync up to your enterprise data stores, user stores. For example, your LDAP or AD, that's corporate-wide, can be synced up so your users and groups can be maintained outside as the authoritative source, and all of those can be pulled in as needed to author security policies and as the policies evolve over time. Okay. So we've also added in 2.5 advanced capabilities around security. So there's dynamic masking that we added, and dynamic column masking and row filtering, and also dynamic policies. Some of these dynamic policies include integration with Apache Atlas, which we'll talk about shortly here. There are a variety of very sophisticated policies that we provide in the Ranger framework, using things like, what is the request context in terms of the time of request, in terms of the IP address or location from this request came, et cetera, and making intelligent security decisions based on all of that information flowing in. Okay, so that's Ranger sort of in a nutshell. On the governance side, we have Apache Atlas, which is our platform component that provides metadata and governance. It's our centralized platform for that within HTTP. Provides these major areas of capabilities, as the first one being data lineage and provenance. So along the entire data lifecycle across different components, as the data gets ingested into Hadoop and moves within Hadoop and eventually exits Hadoop at some point, all of those actions are captured, and the lineage, metadata, provenance information is persisted in a scalable, queryable data catalog that is provided by Atlas. Atlas also provides you the ability to classify and curate the data assets, so you can attach different terms, tags, etc., to the assets to say this is the business context or this is the usage context for this particular asset, for this Hive table or HDFS folder, for example, and provides you a very scalable way to scale to search and query this metadata via Solar indices. There's both a free text search and also a more guided search and advanced search using DSL. We also provide integrations to different parts of the Hadoop ecosystem through a common metadata store, and that supports all of these different ways that you see here. There's two major areas, which is on complete RESTful access to all of the things that that Atlas does, either it's in terms of lineage or in terms of metadata and provenance, and the ability to kind of add your own extensions or write your own custom reporters in case you don't have a connector for that context. For example, if you have your own custom Spark job that's running, you can very easily write an extension that will go and publish the data into Atlas and stitch up the lineage of all of those operations that are happening within those scripts. So in a sense, the idea is, a big idea here being that the modern data lakes, they need new ways to govern because of the cost, the diversity, and agility that is demanded in these environments. And all of these become much more important in a cloud context where all of this data, these clusters themselves are ephemeral, and we'll kind of see how we can apply some of these principles as we go back to talk about how this is integrated with Hortonworks Data Cloud. So this is the other picture that to keep in mind as we talk through this. Ranger and Atlas are already integrated. So as you classify data assets within Atlas, those classifications are automatically published to Ranger. Ranger is one of the few listeners for the Atlas metadata tag sync processes, and Ranger will, in near real time, receive those tags so you can author policies almost near real time as soon as those assets are classified in Atlas, and those tags become available in Ranger. So one of the use cases that our customers often point to is that you can actually create these classifications, create these policies ahead of time, and as and when the data gets put in, it's protected from the time it lands in Hadoop. So it gives you a very nice flexible decoupling of the security policy interface along with the classification interface and the actual ingestion process around that. Ranger also supports these other policies. We'll look at an example of the prohibition policy in the when we look at the demo further down. And there's also time and location. The time and location types of security contexts are for cases where, let's say you have an offshore team and you want to provide access to your offshore team only during their business hours. So in addition to the actual request, which user is making that, we can inspect the context of the request to say what time was this requested and from what IP or region it was requested, to be able to make that decision more intelligently. So we'll look at some of these examples when we run through the demo. So I'll hand it back to Jeff to talk about the cloud.
So with Ranger, Atlas, Knox, you can see they're pretty powerful building blocks when it comes to security at the edge, and then inside of the cluster for policy management, and then governance. So how do we see this actually coming together when we're thinking about ephemeral clusters that are working with cloud storage? So as we stepped back and started thinking about it, we were like, the set of the Ranger, Atlas, and the Knox really, to us, become this set of data lake services that you just want to have available and always be there. And in addition to that, you have to also make sure that schema is always preserved, because you're going to be able to put in policies around Hive, tables, and things like that. So schema also has to always be available. So we look at this idea that you have this cloud storage that's very durable. So you kind of have your S3 and your data in cloud storage. You have workload clusters coming and going. By default, those clusters should be protected around the castle from Knox, and so there's really minimal surface area for people to try to attack, so we can kind of funnel everything for you from a Knox gateway perspective. And then when you go and run these workload clusters that are ephemeral, let's make sure they can just pick up consistent schema, apply consistent security policies, and tie into the same business catalog and have the same tagging that's available. So we look at durable storage, ephemeral workloads, and more longer running services in the middle, which is a little bit different than a traditional multi-workload cluster where you embed that middle set of stuff actually in the clusters themselves. So what we did with Knox, how we brought it into Hortonworks Data Cloud, was try to think, let's just go and make sure that by default, we're able to go and just through a simple set of choices, people can say, what do I want actually to have Knox wired up to by default? So I can have access to either the component UIs, the Embari or Zeppelin UIs, or even just the JDBC interface for Hive, whether it's traditional Hive or Hive LLAP. So we tried to take that core building block of Knox, make it really prescriptive, and give people simple choices to say, I know you want this, let me just try to give you the checkboxes to enable it for you. When it came to schema for Hive Metastore, so your table information and things like that, we looked at how can we help people go and preserve that information in Amazon RDS. So your clusters will come and go, but when you spin up your cluster, let's pick up the schema from Amazon RDS database so that you already have your table definitions there and you're ready to go. So that persists beyond the cluster workload itself. And then we also looked and said, can I spin this up and have my Ranger always available? So I can actually go and have a Ranger that's there when I spin up my cluster, attach it. And similarly, we'll do the same with Atlas. So what we're going to demo here is kind of building on what I showed you in the beginning, but we're actually going to go and try to put this together. So we have files in S3, we have a couple clusters that we spun up, but we attach them to a set of data lake services that include the Hive Metastore, the Ranger, and things like that. So instead of the quick demo, we'll do the longer demo at this point. So I'll switch back over to my browser. And we'll go over to, this is a different data cloud because I've already kind of gone through a little bit of experience of building some stuff out. So building blocks for the shared services, it's going to start with, the first thing is, what's the authentication source do you want us to use? So where are we going to get users and groups from? So how do you go and register that? So your LDAP, your Active Directory, or if you're using simple AD, just whatever you're going to do there, you register it here, so now at least we know a place to get users and groups from. And this is where we'll authenticate against. For Hive Metastore, a building block here is you've registered an Amazon RDS instance, so we have that available, so it's available to use. So these things, we haven't even done any workloads yet, but I put these building blocks in place. So I've got an authentication source and a Hive Metastore. So from a data lake services perspective, I've already actually built one up here. I've gone and created that long-running data lake set of services that includes Ranger. And so this is going to sit here, and this is going to run, and it's available to me right now. And I still am not using it or anything like that. I don't have any clusters attached to it, but I have spun it up, and basically it's here and ready to use. So if I want to go and actually attach something to it and go run a workload, so I can go and attach a cluster, and now I have a choice to say, let me go and use that set of data lake services. Let me go and use that Ranger that's there for me, that LDAP authentication source, that Hive schema that's already there. I'll go and pick the workload that I actually want to run. I can go and sit there and say I want to go run an LLAP type workload. How do I want to configure the instance types that will run inside of there? I can set up to take advantage of spot instances if AWS pricing is good. I can have the cluster actually heal itself a bit. So since we know if a node goes away, we can bring it back in. Here's where I have the option to say, how do I want Knox to be configured for this cluster? And then ultimately, when I go and click create here, what I end up with is a workload cluster that is attached to a Ranger with a consistent set of security policies that's ready to work against S3 data and authenticate users using my LDAP. So I have these two clusters spun up here. One is really around analytics with high-level IP. The second's around data science. That's more around Spark. So I actually want to hand it over to Srikanth again to kind of drill in here and actually show you some of the features and capabilities and dive into the policies and how they're put in place.
Thanks, Jeff. Okay, so we've already spun these two workload-specific clusters up, and remember, these are all talking to the same plane, which has a shared ranger, a shared Knox in the background. So the benefit here is that regardless of how many ephemeral clusters that you're spinning up, you can write policies consistently in one place and have one place to manage that. You don't have to write this, duplicate the policies. You don't have to duplicate all of your Atlas, metadata, lineage, all of that information. So all of that is in one place. So you have this shared set of services that will give you the anchor point to define and manage security policies, your governance, and your access to this whole constellation of ephemeral clusters that are controlled via this particular data lake. So we'll see how that works to just take a quick example. So here's the ranger that's attached to that data lake service. And in here we have, let's see, a few policies. Just take a look at some of the Hive policies here. So hope people can read that. Let me just make it a little bit bigger. Okay. So we have a set of access policies here. We have a set of masking policies and some row filtering policies. So nothing, nothing complex here, just a very simple set of policies here. This is the Atlas that's attached to this cluster. And for those of you who are not familiar with Atlas, it is a metadata and governance solution which has, which has the ability to search this master data catalog. All of the different types of assets sitting within that particular set of clusters is available to you. And remember, all the data here is all ephemeral, sitting out in S3. So none of this data is actually sitting in the HDFS on any of these clusters. It is externally sitting in those cloud data stores, and it's all mounted via, for example, Hive external tables, and becomes available to all the clusters that are part of this constellation. So you don't have to now remount these things or redefine your table, et cetera. You've defined it in one place. It's available as a catalog via the centralized data catalog in Atlas for you to use. So Atlas, for those who might be interested here, here's a drill down into looking at a particular asset. In this case, we're looking at a Hive table. Atlas gives you a very nice picture to kind of see what happened, what are the steps that took place to create this data. For example, we are looking at this table here. This table was, how this was created was there was a Spark job that was run on 3 other Hive tables, which were imported via Scoop. So you can actually see that there's 3 sets of MySQL tables here were scooped in, and then they resulted in Hive tables. They were joined using a custom Spark job to create this table. So all of this lineage, all of this metadata around all of this is available to you, as part of the first class part of the platform, because we have a Hive hook that works with Atlas and harvests this metadata as these changes happen. We also see all the different types of metadata here, and you can attach different classifications. Classifications include tags. In this case, you can attach tags such as PII if it has sensitive data. And if you want to write some data expiration type of policies, you can set different values for attributes on the tags. In this case, we have a tags table, and the tags table is a lease data set. And the lease data set has an expiration date. So in this case, we'll annotate that by way of an attribute that you see here called expiry date. What this means is that this particular table, which is leased from an external entity, the license for that is expired as of the last day of 2015. So today, if anybody tries to access this in the enterprise, they should be blocked. We can write a security policy using Ranger based on this. This tag that you attach to the asset will flow seamlessly into Ranger and be available for you to author policies almost instantaneously. So we'll see how we do that here. Just one second. So there's a tag-based policy. Remember, we had a tag called expires on. And the expires on would show you who can access this data. So in this case, we are saying that only the compliance group is allowed to access this data after the expiration date. Everybody else, which is public, is blocked. Okay? So very simple set of policies that you can write, and then all of this works in conjunction with the classifications that you do in Atlas. Okay? So let's see how this works. So remember we had these 2 clusters. There's one here that's the ephemeral cluster that was used for more of a BI and analytics type of use case with high LLAP, and this is more of a data science use case. So what we have in this, let's say in this enterprise as an analyst, let's call him Joe. So he's trying to access different pieces of data, run some very basic analytics, and then we'll see how all of this kind of plays together. So the analyst in this case is hitting the data science cluster. And then remember, there's no data that's actually sitting in that cluster. All of the data is external in S3 and is mounted via external Hive tables and through the common Hive metastore, and is available via the range of policies with the secure access to each of the individual clusters. So even though he's operating on a particular ephemeral cluster, you can see that all of the security policies will be seamlessly applied in the background. We'll see that when we run one of these. So in this case, we had defined a bunch of masking policies, and you'll see when this comes back that a lot of the data got transformed because there were security policies to say, redact the street addresses, hash the passwords, anonymize the ages, show only the last 4 of the social security numbers, show only the first 4 of the credit card numbers, nullify the medical record numbers, and do this custom masking on this birthday, which says retain the year of birth, but hide the actual month and day of the birth date. This will give you some partial anonymity of that particular customer data. So this security policy was seamlessly applied behind the scenes when this analyst ran this query, and you can see the results here. We also had this notion of a prohibition policy. So what that means is the prohibition policy will let you prevent joining of toxic data sets. In this case, this is a healthcare context, so this analyst is trying to join a zip code, a medical record number, and a blood group. And with this combination, you can re-identify the individual. So say, for example, you have a very rare cancer. If you know the person's zip code and one other piece of information, you can re-identify the individual. So this is to prevent that type of re-identification by blocking this via security policy. So we would have a range of policy here on the access side, which will prohibit the join of those 3 pieces of data. So I'll show that to you very briefly. It's very easy to set up these policies.
Can you figure out all possible combinations of data that could possibly identify?
Now let's hold the questions until we finish the rest of this. Okay. So in this case, the policy is very straightforward. We do a zip code. Somebody tries to join the zip code with these other fields, which is the medical record number and the blood type, and the only restriction is that the analysts are allowed to join this. Maybe other folks such as HR is allowed to join this. Maybe other folks in customer service or policy servicing groups, they're allowed to join this. It's only the analyst group which is prevented from, or prohibited from doing this. So you'll see that in effect when this fails here. Okay, so that is the, and then if we run this, you should see this being blocked, and there'll be a Ranger audit event corresponding to that, so we can go check back in Ranger, and you'll see that this person was blocked because of this policy in effect. Okay, so this is the analyst now trying to run this using the, okay, the analyst was first trying to run the same set of queries and the same exact logic, but they were using simple JDBC Hive. So they were hitting the Hive LLAP service using JDBC, and you can see that all of these got applied. And then the same way, they're doing the same exact operations, but this time what happens is they're using Spark. So you'll see that here, that we're using the Spark driver. So regardless of which engine you're using to access this and how you're accessing this, the same set of consistent policies got applied behind the scenes. And that was because of this fabric that we have built, which says you have these long-running services that are consistently applying security policies, applying governance, and also giving you that, that whole perimeter level of filtering and protection for your APIs or access, and still be able to do this individually on a different cluster basis. So the same user hitting 2 different clusters using 2 different compute engines, seamless policy enforcement, all in one place, without any further setup. So we were just trying to make this very simple and show you how easy it is to set up and use in the cloud context. I think that's pretty much what I had. Let's shift back to Jeff.
All right. So, yep. So just, what we ended up showing there, the two different engines that are independent workload clusters, the same ranger, the same schema, the same data. So it's how we put that together and tried to show it there. So I think you can see some of the power of Ranger there and some of the power of Atlas and some of the power of just having consistent schema. So that was pretty key there. So we do have some guidelines when it comes to just as we were putting together the idea of this shared set of data lake services, just some things to be reminded of that we came up with. So when it comes to ephemeral workloads, stay ephemeral. So your data and your metadata should be in those durable type of storage. So it's S3 or RDS respectively. So your HDFS that's in your clusters, it's really about the temporary or intermediate kind of processing storage. They're not there to actually hold your data because those clusters go away. So your ephemeral workloads, you try to right size the HDFS for the workload you're going to run. You keep it as small as you can, but the data is really meant to live in S3. And the schema and other things are really meant to live longer term in RDS.
Yeah, so the other key things to remember here, and we kind of showed this when we went through the Hive layers. So if you looked at how, actually this may make sense to go back just once. Oops. If you remember in Atlas, you can actually see the location of where some of these tables are. So you can see that all of your data here is sitting in external tables. So that is one of the pattern that whenever you have such ephemeral storage, make sure that all of your tables, all of your Hive tables are external, because you're not mounting any of these tables in any of the ephemeral clusters. They're sitting out with the shared metadata outside, and then they're sitting in S3 for the actual storage. Okay, so let's get back to the slides here. Okay. It's coming up. There it is. There we go. All right, so external tables is the third point here. And then the other key point here is also making sure that your security policies that you're setting up for the buckets match whatever is the least privilege principles that you have for the rest of your enterprise. Make sure that you don't allow too much control in there or make it too broad so that will interfere with all of your other security policies you may be enforcing via Ranger. So if you don't control that at the bucket level, whatever else you do at the Ranger level may be moot because you're giving already a very permissive model for your users. So that is something to keep in mind that is complementary to what you're also doing in Ranger and Knox in terms of how you secure your data assets. Okay, that's pretty much what we had. So maybe Jeff can walk through the takeaways.
So the takeaways with cloud, we're thinking a lot more ephemeral data processing use cases. So ephemeral workloads, working with cloud storage. It's really driving us to this architectural pattern to deploy shared data lake services for the policy schema and Atlas, so you can attach those workloads to it. And really just Ranger, Atlas, and Knox are the building blocks here. And they really enable us to kind of put this all together. So they're great just projects to go check out and use in general, but we're applying them really special purpose here when we think about data lake services. So some of the other places you can go take a look and dig into more detail here. So you can always go and check out Hortonworks Data Cloud. So learn about that, learn about ephemeral workloads, S3 processing, things like that. You can go check out our blog. We just did a release of Hortonworks Data Cloud, so that's out there. You'll see some more blogs coming about ephemeral workloads with Hive LAP and things like that, so just watch that place. And then always just go learn more about the projects themselves that are kind of the building blocks of this for data lake services, so Ranger, Atlas, Knox. Tonight, there's actually Birds of the Feather sessions. So we have a cloud and operations session. So some folks from the CloudBreak team, as well as the Hortonworks Data Cloud team are going to be there, talking about just all things cloud. That's everything. But at the same time, you're going to have to choose security and governance. So you pick one, or unless you have two people, is security and governance, and they're going to be covering everything, soup to nuts, probably more Ranger, Atlas, and things like that.
Ranger, Atlas, Knox, and other security considerations, governance considerations. So,
cool.
Those.
So I think we're just at about the 5-minute mark. So time for some questions. Cool. All right. Yes.
You showed that this works with Amazon. How is the future for Azure looking? I mean,
So with Hortonworks Data Cloud, we specifically focused it on the Amazon experience. With HD Insight, they have a similar type model available with prescriptive kind of ephemeral type clusters that integrate well with cloud object stores like WASB and ADLS. So they have a similar type pattern over there. So it kind of gives those two choices there. So Hortonworks Data Cloud in the Amazon case, HD Insight in the Azure case.
so with HD Insight, you also have Ranger, Knox, and
We have Ranger, and they are in the process of adding Knox. Atlas is coming.
Yep.
So Atlas is not there today in
it's
HD
not
Insights.
there today.
It's not there in HD
Any
Insights.
idea when?
We're working with Microsoft on the roadmap. It depends on lots of other considerations they have, because right now they're more focused on doing the security part for WASB and ADLS. They built the Ranger plugins that should go out first, and they turned on Ranger, I believe, last November in HD Insights, and they are claiming a very high attach rate with that. So they're first focusing on the data lake storage and the securing of those before they turn on the governance services.
Okay, thank you.
Yes.
Is there a way, or is it planned to use a local or on-premise Ranger or Ranger KMS to share on the cloud environment?
Yeah, so the Ranger KMS is special purpose for HDFS TDE. Right now, it only handles that. Amazon comes with the Cloud HSM, which I believe is the same SafeNet Luna or whatever that appliance is from Gemalto. They've just put a wrapper around that service and made it massively scalable by offering that behind the scenes. So we have plans to make Ranger KMS work with the Cloud HSM for offloading the keys. So that should work the same way whether you're sitting on-prem or in the cloud. So we can federate the keys, but then the Ranger KMS, the important thing to understand there is the only key that's federated and sent out there is the master key for all of the encryption zones. The individual encryption zone keys are still within the KMS, the Ranger KMS's environment itself.
All right.
So when you have your cluster through HDC, the only one thing you have to do, I guess you have to, yeah. When you have your cluster on HDC, for Ranger, Atlas, or all the security and governance stuff, you mean that it's kind of, do you have on Amazon instances then to create before, such as RDS and other things?
Yep.
Prepare the environment before?
So switching over here real quick. So what we've done is when people go and create the data lake, then we kind of have a sense of what are you looking to have in that data lake. So that will include Ranger and Atlas. So the idea of we will spin up, whether small or large, like 2 nodes, 4 nodes type system that runs your Ranger, the Atlas, the infrastructure it needs there. So we will provision that small shared services cluster, 2 or 4 nodes, and then everybody else attaches to that type thing. So a similar type model there. But we're trying to keep it out of the cluster is the idea. But yeah, so that was after we did the building blocks, then you do the create data lake, we'll make that small data lake, then it kind of results in this where the Ranger's running inside of there on a few nodes. And then when you create your cluster, you just attach to these.
So the data lake abstraction contains all the shared services, and they can federate and look at the data to provide the appropriate security policies and governance in the ephemeral clusters. So none of these shared services are running in the ephemeral clusters. They're running in the other data lake managed service.
Yep.
Okay, so it's like, it's like a dedicated cluster.
It's a dedicated cluster
dedicated
with a
to
small
governance
footprint.
security,
Yeah.
very small.
Yeah.
Correct. And we're working on the model where we try to keep it small since we're right-sizing it just for Ranger Atlas and the infrastructure it needs. We're also trying to work on the model where all of its information also goes into S3, so you can do stops and starts, because if you're not using it, you want to be able to pause it and at least cut the EC2 spend, and it preserves all of its information in an S3 bucket, so it can be rehydrated pretty quickly. So, we try to do that to make it just right size just for those services, but then also avoid having to double spend, because if you have a ranger in every cluster and things like that, you end up spending for those more than once. You really just want the policies preserved.
So some of the things you're working on is, for example, the ranger audits. We want to write them directly to S3. So even if your shared services infrastructure goes down, you still can bring that back up with, you won't lose any of your audits. Similarly, we're working on trying to see how we can get the HBase dependency also to more of a cloud store. So that way the Atlas's backing store can be made more from a cloud storage perspective. And you can kind of offload that without having a dependency on HDFS.
We're getting the hook on this one. So we'll be around for a few more minutes, but thanks everybody.
Thank you.
And enjoy the rest of the show.
Thank you.